I'm going to go over all of the key formulas that you have to have memorized before you take your digital SAT. All these formulas are not on your reference sheet. So as you watch this video, please take notes so you can go and reference these formulas like right before you take your exam. So the way this video is going to work is I'm going to show you a formula, then I'm going to pull up a question and we'll solve that question together. So I would recommend before watching the solution for each question, try to solve that question yourself, see how far you can get and see if you get the answer right because that's where the real practice is. So, without further ado, let's get into the quadratic section. Okay, so before I start solving questions, I just want to talk about the questions themselves. So, just to give you all a heads up, I would say these questions are among the hardest that you'll see in Math Module 2. So, don't be super worried if you can't solve each and every one. If you can solve in each and every one, I would be pretty confident going into the test if I were you. So yeah, you have that to look forward to. Also, all of the questions from this video are straight out of the tutorial question bank. So if you either want another practice resource or if you just want to take the free practice test, I would head to tutorial.app or click the link in the description. Okay, so without wasting any more time, let's get straight into the first question. So the formula attached to the first question is vertex form, which is y equals a times x minus h squared plus k. It's written over there. And now let's read the question. The graph of the quadratic function f of x equals ax squared plus bx plus c is a parabola in the xy plane. The vertex of the parabola is at the point 3, -8, and it passes through the point 5, 4. What is the value of a plus b plus c? Okay, pause the video right here, solve the question. And now this is the solution. So when you see a plus b plus c, I think they're talking about the a plus b plus c in the standard form equation. Oh yeah, by the way, this video already assumes that you have a basic foundation in math up to algebra 2 if you take the high school course equivalent. So I'm assuming that you know how to factor things already, like you basically know the fundamentals of geometry, like different area formulas and things like that. This is a little bit more advanced. So if you still haven't either taken those classes in high school or if you don't know all the material, I would definitely go Khan Academy and study that stuff because this assumes that you already have that fundamental knowledge. Okay, my bad. Let's get back into the question. So yeah, a plus b plus c is referring to the quadratic standard form ax squared plus bx plus c. So we basically need to find the sum of all of these constants over here. Okay, they also tell me that there's a point at 3, -8 and a point at 5, 4. So the point at 3, -8 is the vertex, right? So we can kind of plug that into our vertex form right here. So y equals a times x minus, and h is the x coordinate. So x or x minus 3 squared plus the y coordinate, which is k. So in this case, -8. Yeah, let me also mention that right here. H, k is the vertex. Okay. So now we also have another point, 5 and 4. So we can still plug this into our equation because they're empty spots for y and x. So I'm going to plug in 4 for y equals a. We don't know yet, so we'll keep a as a variable. 5 minus 3 squared minus 8. Okay, so for these quadratic questions where you're missing an a, the first step is usually to find it. So I'm just going to solve for a. 4 equals a. 5 minus 3 is 2 squared minus 8. So 4 equals 4a minus 8. 12 equals 4a. A is equal to 3. A is equal to 3. Okay, so now that we have our a value, we can actually plug it back into this equation right here. Y equals 3 times x minus 3 squared minus 8. Okay, and now it wants us to find the values of a plus b plus c. So what you have to know is that this vertex form, whenever you FOIL it out or essentially simplify it, you actually end up getting the standard form right here. So if we're able to FOIL out this vertex form, we can convert to standard form because the two represent the same equation. They're just shown mathematically in different ways, right? So if we just FOIL out this equation right here, I'll do it off to the side where there's more space. Y equals 3 x minus 3 squared minus 8. So we need to FOIL out this part of the equation. So we have x, or sorry, x minus 3 times x minus 3. So we're going to get x squared minus 6x plus 9. Plug that back in here. Y equals 3 times x squared minus 6x plus 9 minus 8. Okay, now we just simplify this. So y equals 3x squared minus 18x plus 27 minus 8. 27 minus 8 is 19. So we get y equals 3x squared minus 18x plus 19. Okay, so now that we've converted from vertex form to standard form, you can notice that this is in the same form as what it's asking for in the question. Ax squared plus bx plus c. We have 3x squared minus 18x plus 19. So in this case, a is 3. We already solved that. B is negative 18. And C is 19. Just match that up to the equation over there. And now all we have to do is just do A plus B plus C. So 3 minus 18 plus 19 is equal to 4. So if you said C, then you would be correct for this question. Okay, let's move on to question number 2. So the function f of x is defined by f of x equals a x minus h squared plus k. Okay, so this is our vertex form right here, where a, h, and k are constants. That makes sense. The graph of y equals f of x in the xy plane is a parabola with its vertex at negative 2, 5. Additionally, it's known that f of 0 is less than f of 1. Which of the following must be true? Okay, so it gives us the vertex form equation, right? Ax minus h squared plus k. And it also gives us the vertex, which is negative 2, 5. This is our vertex. Okay, so again, whenever you're given some sort of like vertex form equation and you're given the vertex, you probably should solve for a. That gives you like all the information you need about the equation. So let's plug in f of x equals a x minus 2 squared plus 5. And just simplifying f of x equals, well, x minus 2 is going to be plus 2. So x plus 2 squared plus 5. And we also know that f of 0 is less than f of 1. So this is the only other piece of information that we have about this question. So f of 0 is less than f of 1. Well, like, that doesn't really tell me anything, like, if you just look at it, but I think if we can plug in 0 and 1 for x, that would probably give us a little bit more information. So let me try that. A 0 plus 2 squared plus 5 is less than a 1 plus 2 squared plus 5. Let's just simplify that. So we know that 4a plus 5 is less than 9a plus 5. We also know that 4a is less than 9a. Okay? So there's no way to actually get a from this inequality. I don't think there's anything else I can use in the question. Yeah, there's nothing else I can use in the question to get a. So what does this tell us? Well, this would tell us that a is a positive value, right? Because if a was a negative value, then this inequality would obviously not hold. It would go the other way around. So we know that a has to be a positive value. We just don't know what a is. So let's see if we can kind of guess and check with the rest of the answer choices to figure out which answer choice is correct. Okay, answer choice A. A is greater than k. Well, we know that k is the y value and k is equal to 5. We know that A is positive. Okay, so I don't know if we can say this must be true because although A is positive, right? Like it could be 1, 2, 3, and 4, which would make this answer choice false. So this does not have to be true. So I'm just gonna mark that as incorrect. Okay, B is f of negative 1 is less than f of negative 3. Okay, so actually what we can do is let's just visualize what this graph probably looks like, right? So we know the vertex is at negative 2 and the y value is at 5. So this is our vertex and our graph looks kind of like, or sorry, that's bad drawing. Our graph looks kind of like this, right? So f of -1. Okay, well, let's just eyeball it. -1 is around here, and -3 would be around here. Let me actually redraw this parabola. Looks something like that. Right. So it's saying that it's asking us whether f of -1 is greater than f of -3. Well, what we know about parabolas is that they're essentially two like exponential equations just like joined together, right? So f of -1 and f of -3 in this case, I think they would actually have the same y value because they're both the same distance from the vertex, even though like -3 is obviously less than -1, just in terms of the x value. So I don't know if this is true. I would actually doubt that this is true because we know that -1 is not greater than -3 in terms of their y values, right? So what we can actually do is we can kind of plug this into Desmos because we know that, well, we have our general form equation. F of x is equal to ax minus h squared plus k. So I mean, right now I'd be comfortable marking that as incorrect, but if we just want to check, right? Or sorry, we know that this is 2ax plus 2, and then we know that this is 5, right? So we can just put this equation in Desmos with just giving a some random value like 2 or 3, just some positive value, right? And then we can check if this is true. So let's head over to Desmos. Let's say f of x is equal to ax plus 2 squared plus 5. Let's add a slider for a, and let's say a is equal to 2. So this kind of looks like what we actually drew in that picture. So let's say f of -1, that's 7. Okay, f of -3, that's also 7, right? And if we mess with the slider to say a is 50, yeah, they're still the same value, right? So I can pretty definitively say that B is incorrect. Let's move on to C. F of -4 is greater than f of -3. Yeah, this kind of makes sense, right? So if we just look at the graph, you have -4 right here, right? So f of -3 would be like around here. Well, f of -4 would be around here. So yeah, this is probably correct, but let's just check, right? We have f of -4. Yeah, obviously that's going to be a lot greater. And if we mess with the slider, still a lot greater. So yeah, I mean, I would say this is probably correct. Let's just check answer choice D. A is less than H. Well, we know again that A is some positive value, and we know that H is the X value of the vertex, so H is -2. So yeah, obviously -2 is not going to be greater than a positive value. So pretty clear that C is correct here, but for this one, you did have to use a little bit of logic knowing that A is positive and you have to translate that to the graph. But key takeaway here, besides vertex form, is that solve for A, and even if you don't exactly know what A is, usually you can kind of guess and check on the question just based on whether A is positive, negative. I mean, it's usually not going to be zero. So yeah, if and again, if A is negative, right, then this would actually open downward. So yeah, you can kind of guess and check that stuff, and you can figure out which answer choice is correct. Okay, let's move on to question three. Okay, time to move on to question three. So for the quadratic equation kx squared minus 10wx plus 25k equals 0, suppose it has exactly one real solution and that kw is equal to 144. What is the value of the absolute value of k plus w? Okay, so for this question, we're gonna use something called the discriminant. Discriminant. Okay, I'm not even sure if I'm spelling that correctly. Discriminant. Let's try that again. Yeah, there we go. So the discriminant is equal to b squared minus 4ac. And if the discriminant is greater than 0, we know that there are two solutions to that equation. If it's equal to 0, we know that there is one solution for that equation. And if it's less than 0, then we know that there's zero solutions or no solutions for that equation. Please, 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 please memorize this, write this down in your notes because you have to know it. Like on every test that I've taken, I've seen this showing up somewhere. So please, please, please know this. It's like a must know equation for the SAT that's just not on your formula sheet or anywhere. So if you didn't study this, you wouldn't actually be able to use it on that test. Like you can't find it, right? So let's use our equation kx squared minus 10wx plus 25k is equal to 0. And we also know that kW is equal to 144, but I can't really do anything with that right now. But since we know that this has one real solution, we know that the discriminant has to be equal to 0 here, right? So instead of having to work with this kind of frankly annoying equation, what you can actually do is you can break it down further. So we know that A is equal to K, or actually here, let me do this. So let's just match this up to like the standard form equation, just to make this clear. So we know that A is equal to K. We know that B is equal to negative 10W. Don't get confused by the W, it's just like a constant value, just plug it in. And we know that C is equal to 25K. Okay, now this makes things a lot easier because I can just plug in negative 10W squared, which is I'm plugging this into the discriminant, by the way. So negative 10W squared minus 4 times A times C is equal to 0. And it's equal to 0 because when there's one solution, the discriminant is equal to 0. So let's just simplify this, right? So we have 100W squared minus, well, 4K times 25K is 100K squared equal to 0. So 100W squared is equal to 100K squared. Therefore, W squared is equal to K squared. W is equal to plus minus K. So now we can actually go back and plug this in here, right? So we have two cases. W is equal to K, but W is equal to negative K. Make sure you don't forget that plus minus whenever you're simplifying roots. It's super important. So let's just plug in the first case. So let's call this case 1 and let's call this case 2. Case 1. W is equal to K, so that gives us W times W is equal to 144. We know that W squared is equal to 144. So we know that W is either equal to 12 or negative 12. Okay, let's try plugging in this other one. So we know that K is equal to negative W. So for case 2, let's do negative W times W is equal to 144. Let's divide this negative out. So W squared is equal to negative 144, but this has no solutions, right? There's no square. You can never square a value and get a negative. It doesn't work like that. So this has no solutions. So we can kind of just like kind of cross out case 2. We don't really care about it because there's nothing we can do with it, right? So it's asking for the absolute value of K plus W. Well, so since W is equal to K, let's do again case 1. So we should effectively get the same value for K plus W here. The absolute value of K plus W. Well, let's just double check, right? So W is equal to K, so that we have absolute value of 12 plus 12 is equal to, well, this is just 24. And we have W is equal to negative K. So let's use negative 12. So we have negative 12 minus negative 12. Or wait, okay, this is not right. Let's do negative 12 minus, yeah, negative 12 minus 12. I'm sorry. This is because if you plug in negative 12 for W, you're going to get 12 for K. So you have negative 12 minus 12. And this is also equal to 24 because the absolute value of negative 24, and that's just 24. So we're getting the same equation here. So the answer to this question would be 24. There we go. Let's move on to the next question. Time to do question 4. So the system of equations below has two distinct solutions, x1, y1, and x2, y2. We have this system of equations here, and we also know that if x1 plus x2 equals 10, what is the value of k? Well, what first jumps out to me whenever I read this question is the x1 plus x2 equals 10 part. So the formula to know for this question is that negative b over a is the sum of solutions. This is like a handy little formula to know because it tells us that the two distinct solutions have x values of x1 and y2, or x1 and x2. So we know that negative b over a is equal to x1 plus x2. Okay. Also, another thing to know that's not really relevant to this question, but it's important, is C over A is the sum of or not the sum, sorry, the product of solutions. Product of solutions. And when I talk about A, B, and C here, I reference the quadratic standard form equation ax plus b equals 0. So A, B, and C are right here. Okay, so now that we have understood that little part, we can solve the rest of this question, right? So first thing to do is to set these. It's to solve for this. What's it called? System of equations, right? So we know that they're both equal to y, so we can set kx equal to x squared plus 2x plus 1. Now let's set that equal to 0. So we know that x squared plus 2x minus kx, or sorry, this is kx equal to plus 5, not just kx. Kx plus 5 plus 1 minus 5 is equal to 0. And we're setting this to 0 so we can actually compare it to our standard form equation that I just talked about. So this allows us to kind of utilize that negative b over a formula. So in this case, a is equal to 1 because this is essentially the same as 1 x squared. B is well, okay, so there are two terms that have 2x minus kx. So what you can actually do when you have this, right, is you can pull out an x. And you can say x times 2 minus k, right? So I mean these two are mathematically equivalent. So b is equal to 2 minus k, and then c is equal to 1 minus 5, which is negative 4. So yeah, we don't really need c for this question because it's asking for the sum of solutions, and the sum of solutions is negative b over a. So negative b in this case is negative 2 minus k, and then a is just 1, right? So we don't really need to know this. And we know that the sum of the solutions is equal to 10. So I just set this equal to 10. Let's just multiply out this negative. So we have negative 2 plus k is equal to 10. Add 2 to both sides. K is equal to 12. What was the question asking? Oh, it's just asking for the value of k. So it's obviously not A, not B, not D. It's just C. So I know I haven't been using Desmos for a lot of these questions, and you could use it for this question, right? I'm actually going to show you how to use it. But the thing is, imagine if this was a free response question, right? For Desmos, what you would usually do is you would just like guess and check all of these answer choices for K just to see like which one is correct. But I mean, for some questions, that gets a little hard, right? Like imagine this was like a free response question, then you wouldn't able to run that method, right? It wouldn't work because you had nothing to guess and check it against. I guess you could mess with the slider, but I mean that's probably going to take more time than just solving this question, and there's no guarantee that you actually find the right answer, right? Like what if the answer is like some crazy repeating decimal? Then like you're not going to get it right. So that's why I actually said in my like other video, which is how to get an 800 on SAT math, that you need to learn how to do these formulas in case you come across like a super hard free response question that has like a crazy decimal. Like you're not going to be able to get that question right unless you know the formula. So I would say that it's definitely worth it to learn the formula. That being said, let's say you came across this question and you did not know the formula. This is how I would solve it, just to kind of increase your knowledge on Desmos, right? So let's actually head to Desmos. This is from the previous question. Let's get rid of that. We know that y is equal to, what was it? X squared plus 2x, what was it, plus 1. And we also know that y is equal to kx plus 5. And sorry, 5. Let's just add a slider for k. So it has two distinct solutions, and x1 plus x2 is 10. So let's try the first answer choice for k, which is 8. So yeah, I mean, clearly the solutions are not going to be 10. There's some decimal value and some negative value. That's not 10. It's definitely not 8. Let's try 10. And also using Desmos like this is also a good way to check your solution too, by the way. So our solution, there's another decimal. So yeah, probably not going to be it. If I scroll back up here. So that's 8.47 and then some negative value. So that's also not 10. Next answer choice is 12. So this should give us 10 actually. The solution, first solution is negative 0.385, and this is 10.385. So yeah, 10.385 minus 0.385. Sorry, it would give us 10, which is correct, right? X1 plus x2 is 10. So yeah, that's how we can verify our answer and make sure that the correct answer is C. But imagine if we didn't have that free response, like if we didn't have like free response if it was a free response question, sorry. Let's say it was a free response question, you're messing around with the slider, right? I mean, you would have to check these decimals like constantly. So that would get really annoying. So it is really good to know the formula. But yeah, let's move on to the next question. Okay, time for the last question. So consider the system of equations, and then it gives us the system right there, where k is a constant. If the system has exactly one real solution, xy, what is the sum of all possible values of k? Well, it tells us that we have exactly one real solution, so that means that I'm going to use my discriminant and the sum of all possible values, which is negative b over a, like we discussed in the last question. So again, similar to the last question, we have like we have a system here, but it's not like a y equals and y equals type of situation. So I can't just set them equal to each other, but what I can do is I can substitute 2x minus k for y. So, and then simplify that for k. Okay. So x minus 3 squared plus, then we substitute right here, and then we'll have plus 1 squared is equal to 25. So we need to simplify this. That actually might take a while. X squared minus 6x plus 9. That one's easy. But this one, I can't really simplify that in my head. So what we'll do is we'll set that off to the side, and we will multiply this out. 4x squared minus 2. And by the way, if you don't know what I'm doing, I'm just like foiling this out. 2kx plus 2x minus 2kx plus k squared minus k plus 2x minus k plus 1. Okay? So now that I've simplified that, what I'll do is I'll actually get rid of this. And I'll put this back over here. I need to make that a little bit smaller. Put that back over there. And set that equal to 25. So now we need to simplify this again. We need to simplify like terms in this equation. So I think the easiest way to do it is just to highlight which ones are like terms. And we just need to add those up. So we have our x's, we have this little string of x's right here, and we have 2x, and then the rest are just like constants. Like that. Okay. Let's now add these two. So we have 5x squared, and then now we have minus 2kx, so that becomes minus 4kx, and we have 2x minus 6x and 2x, so that's going to be negative 2kx, or no, sorry, just negative x, because 4 minus 6 is negative 2. And then for our constants, we have k squared. We have, sorry, we have negative k and negative k, so negative 2k. We have 9 plus 1 minus 25. So that's actually going to be negative 15 is equal to 0. Simplifying further, we have 5x squared minus, let's actually make this plus minus 4k minus 2. I'm just taking out the x here, just factoring that out, and then we'll just keep our constants the way they are. Okay, now we need to, okay, yeah. So the question told us that as one the why is my pencil not working? Oh, wait, my pencil is not working. Let me put it on charge and I'll cut back. Sorry about that. My pencil died, but now it's charged and we can continue, right? So the question told us that, oh wait, once we have this, the question told us that we have only one real solution, right? So that means we can plug in our discriminant here, b squared minus 4ac equals to 0 because it's only one real solution. This is a, this is b, this is c. Yeah. Okay, so we can plug in negative 4k minus 2 squared minus 4 times a is 5, and then this is k squared minus 2k minus 15. Okay, and this is equal to 0. So this is going to be negative 4k minus 2 times negative 4k minus 2. This is 16k squared, and you have plus 8k plus 8k, so that's going to be plus 16k again, and then plus 4. So we have, let's actually remove that. So we have this minus, so this is 20, so we have minus 20k squared plus 40k because it's minus 20, so make sure you remember that. And then minus 20 times minus 15 is 300. So again, we're going to have to simplify like terms. So we have these two, we have 16k and 40k, and then we have like the rest of the constants. So 16 minus 20 is negative 4k squared. Then we have 56k, and then we have 304 is 0. So just to make this a little bit easier, I think we can divide out negative 4, right? Obviously, we can take out of here. So 56 divided by 4 is what, 17? Not 17, it's 16, right? Yeah, should be 16. Yeah, I think it's 16. And then this is 75 times 4 is 300, so it's 76. Think that's right. So k squared minus 16k. Wait, let me. I might be tweaking. Wait, 40. Wait, it's not 16. But what am I saying? It's Wait, it is six, bro. I don't know why I'm tweaking. 16k plus, or sorry, this is minus 76. Uh, yeah. Okay, I'm tripping. My bad. Okay, so now that we know this is like our final equation where we can solve for k. And it's asking for the sum of all possible values. So the sum of all possible values, like we stated earlier, is negative b over a. So this is b and this is a. So we would have negative 6. No, wait, okay, this is not correct. I don't know why. What is 56 divided by 4? Oh, it's 14, bro. What am I doing? Yeah, that's why I'm like tweaking, bro. So yeah, we have negative 14 over, this is 1. So this is equal to 14. So yeah, I'm pretty sure 14 is the answer. Yeah, 14 is the answer. And then let's say we wanted to do, this is the sum of solutions. And I know it asks for the sum of solutions, but let's say the question is asks for like the product of solutions. So since we didn't get to do this last time, we have that's equal to C over A. So this is C, so we have, or C times A, not C over A. C times A. So we'd have negative 76 multiplied by 1. So that answer would be negative 76. Yeah, I think that's the hardest problem I've ever done. So if you're able to solve that question, like I'm pretty confident you will get every quadratic question right. I mean, if you're not able to solve this, like don't worry. Like that took a long time to solve. Um okay, yeah. So that wraps up the quadratic section, and I think this video is getting a little bit long. So what I'll do is I'll divide the video, like the formula video, into two parts. So this is part one, and then part two will already be up on the channel by the time you watch this. So that'll be on like geometry and triangles and things like that. So yeah, definitely watch that as well. It'll be super useful. And again, tutorial.app if you want to see more questions like this. All of these questions were straight out of the tutorial question bank. I didn't modify them at all. So yeah, if you want a really high quality practice resource, please check out tutorial, and that'll be it from me. Thanks for watching, guys.